Bismillahirrahmanirrahim. Welcome to my YouTube channel Geeky Math. Today I am going to share solution of physics grade 9th Cantab publisher. Chapter number 11 topic magnetism. Multiple choice questions. Question number 1. Which of the following describes the force between the north pole of one magnet and the south pole of another? Option A repulsion, option B attraction, option C no force, option D gravitational pull. So the correct option is option B attraction. Opposite poles of magnet attract each other. Question number 2. When a magnetized material and unmagnetized material are brought close to each other, they will option A repel each other, option B attract each other, option C have no effect on each other, option D cause the unmagnetized material to become permanently magnetized. So the correct option is B attract each other. A magnetized material will attract an unmagnetized material, temporarily magnetizing the latter. Question number 3. Which of the following best describes the neutral zone that exists between the similar poles of two magnets? Option A. It is the area where the magnetic fields of the two magnets overlap and cancel each other out, resulting in no magnetic force. Option B. It is the area with the strongest magnetic force, attracting metals with greater intensity. Option C. It is the region outside the influencing of both magnets where magnetic forces are strongest. Option D. It is the space where electric fields interfere with magnetic forces, creating a zone of electrical charges. So the correct option is A. It is the area where the magnetic fields of the two magnets overlap and cancel each other out, resulting in no magnetic force. The neutral zone is where the magnetic fields of two similar poles cancel each other out. Question number 4. If a north pole of a magnet at a specific point in a magnetic field experiences a force towards the left, then the magnetic field direction at that point is option A to the right, option B upward, option C downward, option D to the left. So the correct option is B upward. If a north pole is attracted to the left, the magnetic field lines must be pointing upward to exert a force towards the left on the north pole. Question number 5. Which of the following statements best describes the difference between magnetic and non-magnetic materials? Option A. Magnetic materials can conduct electricity while non-magnetic materials cannot. Option B. Magnetic materials can be attracted to a magnet while non-magnetic materials cannot. Option C. Non-magnetic materials have a higher density than magnetic materials. Option D. Magnetic materials are always metals while non-magnetic materials are non-metals. Correct option is B. Magnetic materials can be attracted to a magnet while non-magnetic materials cannot. This is the key difference between magnetic and non-magnetic materials. Magnetic materials are attracted to magnets while non-magnetic materials are not. Question number 6. What distinguishes temporary magnets from permanent magnets? Option A. Temporary magnets can generate their own magnetic field without any external influence. Option B. Permanent magnets can only be magnetized by strong electric currents. Option C. Temporary magnets retain their magnetism only when exposed to an external magnetic field. Option D. Permanent magnets are always made of soft magnetic materials like iron. Correct option is C. Temporary magnets retain their magnetism only when exposed to an external magnetic field. This is the key difference between temporary and permanent magnets. Permanent magnets have a magnetic field that is intrinsic to their material, while temporary magnets require an external magnetic field to maintain their magnetism. Question number 7. Which type of material has magnetic domains that are easily aligned in an external magnetic field and retain their magnetism? A. Ferromagnetic, B. Paramagnetic, C. Diamagnetic, D. None of these. So the correct answer is option A. Ferromagnetic. Ferromagnetic materials have magnetic domains that are easily aligned in a magnetic field and retain their magnetism, making them strongly attracted to magnets. Question number 8. Diamagnetic materials are characterized by option A. Strong attraction to magnetic fields, option B. Retaining magnetism after the external field is removed, option C. Having all their electronic spins paired, option D. Having unpaired electrons. Correct answer is option C. Having all their electronic spins paired. Diamagnetic materials have all their electrons paired, resulting in a weak repulsion from magnetic fields. Question number 9. The stroking method of magnetization involves heating a material to a high temperature, option B. Rubbing a material with a magnet in one direction, option C. Placing a material in a strong electric field, option D. Striking a material with a hammer. Correct answer is option B. Rubbing a material with a magnet in one direction. The stroking method involves rubbing a magnet along the material in a consistent direction to align its magnetic domains. Question number 10. The Earth's magnetic field, option A, aligns with its geographical north-south orientation. Option B is opposite to its geographical north-south orientation. Option C is strongest at the equator. Option D does not affect the atmosphere. Correct answer is option B is opposite to its geographical north-south orientation. The Earth's magnetic field is oriented roughly north-south, but the magnetic north pole is located near the geographic south pole and vice versa. Question number 11. The Earth's magnetic field protects life on Earth by option A. Reflecting sunlight, option B. Deflecting cosmic radiation and solar wind, option C. Providing oxygen, option D. Regulating temperature. So the correct option is B. Deflecting cosmic radiation and solar wind. The Earth's magnetic field acts as a shield, deflecting harmful charged particles from the sun and the outer space. Question number 12. Many birds and turtles use the Earth's magnetic field for option A. Finding food, option B. Navigating during migration, option C. Maintaining body temperature, option D. Reproducing. So the correct option is B. Navigating during migration. Many animals, including birds and turtles, use the Earth's magnetic field to navigating long distances during migration. Question number 13. Which of these materials would be classified as a permanent magnet? Option A. Soft iron, option B. Steel, option C. Aluminium, option D. Copper. So the correct option is B. Steel. Steel is a common material used for permanent magnets. Question number 14. In which device would you most likely find an electromagnet? Option A refrigerator magnet, option B a digital clock, option C an electric fan. Option D, a solar panel. So the correct option is C, an electric fan. Electromagnets are used in many electrical devices, including electric fans. Question number 15. When a non-magnetic material is brought close to a magnet, it will option A, become temporarily magnetized. Option B, repel the magnet. Option C, attract the magnet. Option D, remain unaffected. So the correct option is A, become temporarily magnetized. A non-magnetic material can become temporarily magnetized when brought near a magnet. Question number 16. The main hazard of placing a strong magnet near electronic device is option A, overheating the device, option B, increasing the device's energy consumption, option C, erasing or distorting data, option D, making the device magnetic. So the correct option is C, erasing or distorting data. Strong magnetic fields can interfere with the electronic data stored in devices. Question number 17. The North Pole of Earth's magnetic field is actually located at the option A, geographic North Pole, option B, geographic South Pole, option C, magnetic equator, option D, outer space. So the correct option is B, geographic South Pole. The Earth's magnetic North Pole actually located near the geographic South Pole. Short questions of chapter number 11. Question number 1. Why does a compass needle point towards the Earth's magnetic North Pole? Answer. The Earth's magnetic field is generated by the movement of molten iron in its outer core. This field creates a magnetic North Pole that is slightly offset from the geographic North Pole. A compass needle, being a magnetic object, aligns itself with the Earth's magnetic field, pointing towards the magnetic North Pole. Question number 2. What is the significance of the Earth's magnetic field being opposite to its geographic north-south orientation? So the answer is the Earth's magnetic field being opposite to its geographic north-south orientation is significant because it helps protect life on Earth by deflecting harmful cosmic radiation and solar wind. This protects us from the harmful effects of these particles, which can damage DNA and cause mutations. Additionally, the Earth's magnetic field is important for navigation as it follows animals and humans to orient themselves. Question number 3. How does the spacing between magnetic field lines relate to the field strength? So the answer is the spacing between magnetic field lines is inversely related to the field strength. Where the lines are closer together, the magnetic field is stronger, and where they are farther apart, the magnetic field is weaker. This is because magnetic field lines represent the direction and magnitude of the magnetic force. Question number 4. What role do magnets play in the functioning of a hard disk drive? Question answer is magnets play a crucial role in the functioning of a hard disk drive. The hard disk drive stores data on a series of magnetic disks, and magnetic head is used to read and write data to these disks. The head is positioned over the disk and generates a magnetic field that interacts with the magnetic material on the disk's surface. This interaction allows the head to read the existing data or write new data to the disk. The magnetic field is controlled by an electromagnet within the head. Long questions. Question number 1. Can you explain quantitatively using the domain theory of magnetism, how materials can be magnetized and demagnetized through methods such as stroking, heating, orienting in a north south direction, and the use of a solenoid. So the answer is domain theory explains magnetism as the result of tiny regions within a material called domains, where the magnetic fields of individual atoms are aligned in a non magnetized material. These domains are randomly oriented, cancelling each other out. Stroking. When a magnetic material is stroked with a magnet, the external magnetic field aligns the domains in the material in the same direction as a magnet, magnetizing it. Heating. Heating a magnet, you can cause the domains to become randomly oriented again. Demagnetizing it, this is because the increased thermal energy disrupts the alignment of the domains. Orienting in a north south direction. Placing a magnetic material in a north south direction aligns the domains with the Earth's magnetic field, magnetizing it. Using a solenoid. A solenoid, when carrying a current, produces a magnetic field. If a magnetic material is placed inside the solenoid, the domains will align with the external field, magnetizing it. The direction of the magnetizing depends on the direction of the current in the solenoid. Question number 2. How can soft magnetic materials such as soft iron be utilized to provide shielding from magnetic fields, and how it is useful for electronic instruments which are sensitive to magnetic field? Correct answer is soft magnetic materials such as soft iron can be used to provide shielding from magnetic fields due to their high permeability. This means that they can easily become magnetized and demagnetized, allowing them to absorb and redirect external magnetic fields. To shield electronic instruments from magnetic fields, a soft iron enclosure or layer can be placed around the instrument. The enclosure will attract and absorb the external magnetic field, preventing it from reaching the sensitive components of the instrument. This is particularly useful for devices like computers and audio equipment which can be affected by magnetic interference. Please like my video to motivate me. Let me know in the comment section which type of content you want regarding physics and maths. Don't forget to share it with your friends and subscribe my channel as well. Thank you.